Okay, today, so what we're going to do is we're going to look first at something called expected number, and then we're going to explore another way that probabilities can be organized, which are in two-way tables. Two-way tables are your friends. Trust me, they are so efficient at organizing these probabilities, and you'll see that. And you must be able to do it because it will be on your assessment. You all have to create a two-way table and then find probabilities from it. Okay? Now, are they always the way to do it? No. If you're rolling a die, that's just simple probability, right? But you'll see some examples of why they are so important. Okay? So expected number and two-way tables. You use the word expected all the time. If you expect something, that's simply what you expect to happen in a given situation, right? So an expectation is a pretty certain kind of idea, isn't it? And that's what's happening. We're going to be looking at what we expect to happen in a given circumstance. For example, I expect, since we have 11 students in this class, I expect to see 11 students in this class, right? Now, is it always perfect? No. We've got some people absent today, right? So it doesn't always happen exactly that way, but that's my expectation. You have the expectation that I'm going to be here. Maybe on time one day. All right, so that's what we're thinking about when we're talking about expectation. What we're going to do with expectation is we're simply, for expectation, we're talking about what we expect to happen to a given number of items / people, right? Could be any kind of things, okay? Given a probability. For example, if I knew that the probability of one student being absent every day in this class was not going to happen, right? I could figure out the probabilities for being absent for this class, and then I can apply that to the 11 students who are in this class. And then from that, I can get an expectation of what's going to happen. Again, probabilities are not set in stone. These are theoretical probabilities or experimental probabilities. They just describe what normally happens, the chance of something happening, right? It doesn't really give you a firm number. Okay, so we're going to look at a few of those. So just keep that big thing, expectation, in your mind. So expected number in probability is the number of times you expect a particular event to occur in a set number of trials. And I don't like that definition. It's okay. But it's very wordy. Okay, but expected number, simply the number of times or how many times you expect something to happen in a set number of trials. Well, I think the word trials messes with you a little bit because really what we're talking about is a set number. So say like I have 1,000 light bulbs. That's what they mean by trials. There are 1,000 of them. So don't let that word trial throw you. It can also be thought of the average result you can get. Okay? And again, don't try to write down every single word from the Education Perfect screen. Just think about what I'm saying and about what I'm underlining. Those are the things that are really key. And there's a simple formula for it. Okay? And you will need to know this formula. I don't think this formula is going to be given to you on your formula sheet, so you need to know this formula, but it's a very simple formula. E stands for expected number. N always stands for number. There you go, the number. And P, what do you think P is? Probably probability. There you go. So it's simply the number of items you have times the probability that you got. Now again, you can use probability in different ways. So if I give you probability as a fraction, you can multiply with fractions. Or you could change that fraction into a what? Decimal, right? A decimal would be fine as long as it's not a repeating one. Yeah, then the fraction would be a better option. And they may also give you probability as a percent. Now, you can use your calculator to just do the percent, multiply times the percent, that's fine. Or you can change the percent into a decimal, right? Just by moving the decimal point, okay? But your calculator can also do multiplication with a percent if you don't want to, if you want to make sure that you're maintaining accuracy and not making small errors along the way, okay? So that's it for the formula. So they're going to give you the expected number, the number of trials, and the probability. So let's look at an example really quickly. The probability of a AA battery being faulty is 0.0035. What is the expected number of faulted batteries in a shipment of 10,000? So how many batteries am I testing? 10,000, right? So my N is 10,000. They have this written for you, but I'm just writing it for effect. The probability that they're faulty, 0.0035. And to find the expected number that are going to be faulty, that's what I'm looking for, right? The expected number that are going to be faulty, all I have to do is take those two numbers and multiply them together, which gives me an expected value of 35. So out of those 10,000, I can expect, now that's not a definite, right? But I can expect that 35 of them are going to be bad. Do you love this lesson? Okay? You just have to remember what it is you're looking for. How's that look? Too easy? Good. I like easy. Okay? Now, you can also have compound probabilities. Now, I didn't really use that word, but that's the and/or statements, right? More than one probability, compound probabilities. So here we have the probability of green or blue. What does the word or mean in probabilities? Add. Good. So you're going to be adding them. So find the probability of green plus the probability of blue. And so this experiment, you have a spinner with 5 equal colored sections. So there's only one color per section out of the 5. So the probability of a green, there's only one green out of 5 sections, so that's 1/5. Plus the probability of blue, there's only one section out of the 5 that are blue, so 1/5. And adding those together, they just use the calculator to add them together and gives you 0.4. I would be perfectly happy with 2/5. You do not need a decimal. Going through these, there doesn't seem to be any rhyme or reason why they use a decimal sometimes, a fraction sometimes, whatever, okay? Unless they're just trying to make sure that you understand that it's very flexible. So a decimal answer would be fine. Now, but that only gives us the probability. We want to see, then, what would the probability of getting one of those two things happening, because we have the probability of either or, right? So we want the probability of that happening out of how many trials? 200 trials? So we simply use our formula. The number of trials times the probability that we derived, and that's going to give us 80. Okay? All right. Now, here's a good one. And this came up, I think Shreya asked this question yesterday or the day before. So a pond contains 480 fish. 220 of these are goldfish. If you selected 130 from the pond, how many would you expect to be goldfish? So expectation, how many would you expect? Okay. Well, first we need to find the probability of goldfish, which they've done here. The probability of goldfish, there are 220 goldfish out of 480 fish, right? And they've simply reduced the fraction this time instead of turning it into a decimal. Could you have turned it into a decimal? You bet. Doesn't matter, right? And then we have to find the expected number. Now be careful here. We want to know if we selected 130 fish from the pond. So that's how many we've selected, right? Not the 480 fish that were originally there. So we had to get the original probability by the total number of fish, but now we're talking about selecting 130 of them. What is our expectation out of that 130? So be sure to read carefully. Again, that's the killer in probability. So what number? 130 times what is our probability? Okay. And y'all want to do that real quick? I'm purposely hiding it because I don't want you to see what's going to happen yet. Somebody want to put that into your calculator and come out with that? Oh, come on, ladies. Remember what's supposed to be on your desk right when you come in? Paper, pencil, calculator, ready to go. Okay. 59.58. 3 blah, 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 blah. Okay? Okay? So, then out of those 130 fish, I expect 59.8 of them to be goldfish. Good to go? No. I don't want to get a little over half a goldfish, do you? Yes, you bet. Okay? So, this is where the discrete and continuous comes in that you were talking about, right? We need discrete numbers here, not continuous numbers, because you can't have part of a goldfish. So that means that this number will have to be rounded to 60. Now, we haven't been rounding because we have been talking about just inanimate objects, right? But if it is an object where you have to have a whole object, living things especially, right? Okay, don't like to be cut in half. Yes?
Even though it's 59.5, why would you round it up? Because if that's the expected number, and the expected whole goldfish should be 59 and not 60.
Well, you can do it either way. You could round it up or round it down. Remember, probability is kind of fuzzy math, right? So really, if I were answering this, you might say 59 or 60. Either one of those answers would be perfect. Both of them would be even better. Okay? Because really, it's more than 59. So your rounding rules would tell you to round up. So either one of these answers would be fine. Most people would probably round up to 60, but you could also round off that part of that goldfish, right? Excellent question. Where it's going. So you'll see when they give their answer, which is why I was hiding it, you would expect 59 or 60 to be goldfish. Good job. That's where I was going. Okay. All right. So you can either round down, round up when it's objects like this, when you're doing the expectation. It's not going to make any difference to your answer. How's that look? Okay. So if I was measuring light bulbs, would I have a decimal light bulb? No, we know that one's not going to work, right? So that some things need to be rounded to whole numbers, particularly live things, okay? All right. There you go. That's going into your homework now, so you'll see those later. Just a couple of those for you to work on. How does expected number look? Pretty darn easy, I hope. So let's move in to two-way tables now. Two-way tables are going to be a really important part of our exploration in probability. And two-way tables are simply a way of displaying all of the things that possibly will happen. Okay? Two-way tells you that you're going to have a row at the top, and a column on the side, and the intersection of those will be where the data goes. So for example, in this one, this two-way table has every part of it. You see that there are, keep doing that, items along the top, items up and down, right? And the intersection of those items is two distinct categories, right? And that's where you get two-way table. What I want to point out to you are these two. Every two-way table should include totals going across and totals going up and down. And this one is particularly important for us in probability because that's the total of what? Everything. Okay? It's the total of the totals. So how many different objects are represented in this chart? 31. Right? Okay. Now, how many shirts are represented in this chart? 16. There's a total of 16. How many items of clothing does Ricardo have total? 9. Right? So you have different totals. But this last column is the total of everything. Now, we need to be careful when we're working with these and listen and find out if there are any, if we're using the entire total or if we're using parts of it. And we'll talk a little bit about that as we go forward. Okay? So everybody see how the table is read? So how many pants does Terry have? Just one pair. That sounds sad, but okay. All right. Okay, so let's look at some probabilities. Let's see, did they give us some probability examples from that? I might have gone a little too fast. There we go. So what is the probability? What is the probability that a randomly chosen item is a shirt? So, are we limiting it to anyone's shirts in particular? No, just shirts. All shirts, right? So, all shirts means the total number of shirts, right? And we're talking about any randomly chosen item, right? So that means that our total number of outcomes is going to be all of the items of clothing, right? So that gives us a probability of 16 over what? 31. Okay? Super easy when you have these organized in a chart. Okay? What is the probability that a randomly chosen item was a tie from Terry? So we want it to be a tie, and it specifically has to come from Terry, who owns 1 pair of pants and 5 ties. That's very odd. Okay? How many ties does Terry own? 5. And we're randomly choosing that out of all of the items of clothing, which is how many? 31. Okay? So you see how easy it is to read two-way tables. What is the probability that a randomly chosen item is not from Terry? Yeah, there you go. It's really easy because all you have to do, remember, is if he has 5 of the 31 items, okay, so whatever his items are, he has 9 of the items out of the 31, but we want what he doesn't have, so those are, in other words, those 2. So you can either add those 2 up or subtract the weight from his items. Okay, so you were doing ties, so that's okay. So these items didn't belong to Terry, so we could either take 13 plus 9 and put that over there at 31, or if we know he has 9 items, we can take 31 minus 9 and the rest don't belong to him. So either way you want to do it is perfectly fine. Okay, so 13 plus 9 is going to give you out of, will that reduce? Nope. So there you go. Okay. So 2 ways to do it. You could either add the things together or subtract his away. So if you have his. Now, if they'd asked you what is the probability that a tie didn't belong to him, then yeah, you had exactly the right idea, just different kind of way. Okay? Good job. Let's look at the next one. Toby asks all the students of his school if they have any brothers, and if they have any sisters, he records the results below. What is the so you see we have items going up and down and across, and we have our total columns. Sometimes they will give you these charts where you have the items but not the totals. So you're going to have to put in the total columns. Well, total just means add them together, right? So that's not a big deal. What's the probability that a random selected student has at least one sister but no brothers? Okay, so we're talking about sisters here with no brothers. So where is that? So sisters with no brothers. Can I use the total under no brothers? No, because I have another qualifier, right? They do have sisters, so I can't use that. So it has to be the 15, right? Out of everybody? Yes. So out of the 65? which of course will reduce. They'll both divide by 5 at least. Sorry? 3 over 13. There we go. Okay? So think about the qualifiers here. They're giving you qualifiers. So it's not just everybody who has no brothers. It's people who have sisters and no brothers. So it's the intersection of those two when they give you more than one qualifier. Okay? So be careful about when you can use the total and when you need to go to just the intersection. Okay. All right. Hold on just one moment. So that was from your homework. I just did your first homework problem for you. Sorry. You're like, who cares? Do them all. All right. Sometimes we're only given some of the information from a two-way table, and we need to work out the missing values, which is no big deal because we're always talking about totals. What does total always mean? Add. Yeah, you're just adding things together, right? Well, if I have a total and I want to find a part, that's not addition, but what? Subtracting. Subtract what you know from the total and you'll get the rest of it. Okay? So you're going to see some that you have. So in this case, they just give us a list of information and they want us to construct a two-way table. Okay? So I'm going to do that. It's going to be kind of messy for me here because I don't have that much space. A new drug is being trialed with side effects reported for some of the trials. Some of the trials. So does that mean all of them had side effects? No. Okay? So I know that one of my category is going to be side effects. And the other one is going to be what? No side effects. Okay? Make sense? So they don't even tell me what one of them, they tell me what one of them is going to be, and I can assume then the other one is not. A placebo was used in some of the trials. Okay? So a new drug and a placebo. So they either took the drug or they took the placebo. So those are my other categories. Took the drug or they received a placebo. So building a table out of that, I'm just going to put side effects, SE, or not side effects in SE. You can abbreviate as much as you want to, but make sure that it makes sense to you. Don't use S twice or something like that, okay? That's perfectly fine. So, now I don't have any numbers in there. And what else do I not have? Any places for totals, right? But I know where those are going to be. Sorry, I'm writing over the words here. So I know that this is going to be totals across here. And then I'm going to have another column of totals there. Make sense? So make sure your two-way table has all the pieces that you need. So let's say there were 120 trials recorded in total. Bottom right. 120 absolute total everything, right? There were 60 placebos administered. So the total placebos down here at the bottom, 60. Okay. There were 12 trials where the drug was taken and there were side effects reported. So that's side effects and drug. There you go. And what was that, 12? Okay. There were 5 where the placebo was taken and there were side effects reported. So that's placebo and side effects. So where's that? In the middle top one. Okay? So they'll give you the information and it's pretty clear. Now we can get the totals. Up here, that's easy. 12 plus 5 will give us a total of 17. Good. Now, to get the others, what I need to do is I can't add them. I have to start subtracting because I know totals and I know part. So I just subtract to find the difference. So here, to get this one for under placebos, 60 minus 5 is going to give me 55. Good. Here, 120 minus 17 gives me one what? Okay, 3. There you go. Can you see it? Sorry, 103. Okay. 120 minus 60 gives me 60. And 103 minus 55 gives me 48. Is that what you said? Okay. How's it look? So if you know some of them, you can generally find the others. Okay? Now be careful. They can try to be tricky here. And they really like to on the assessments. So be really careful about the wording of them. And now we have enough information to be able to answer questions from that. Okay? Now, I'm not going to do the questions from this because they're just very straightforward questions like with the ones we had before. Instead, I want to show you the next thing. Okay, so here they're just doing the chart, putting it. They did a little different. They put side effects at the top and drug and placebo. Does it make a difference? Absolutely not. Same things. And then they did the probabilities. Okay, so then you're going to have some that you work. Now, let me see. Thought that we had some conditional probabilities in this. Let me see. Maybe not. So it's in the next one, two-way tables. So let's look at this one because sometimes you're going to find that when you have the two-way table, then they're going to give you some conditions that have to be met. And so for these conditional probabilities, something has to happen first. So what's going to happen is you're going to be using just one column or one row of the table to get all the information you need. We kind of did that just a moment ago. So sometimes if an event is influenced by a previous event, you're only going to be using a reduced or restricted part of it. And so usually you see the words if or given. Given means that given the fact that we did this already, right? That's what they mean by using that term. So 3 coins are tossed. If the first 2 coins turn up heads, find the probability the last coin is also a head. So you see there's a condition on there, isn't there? That the first 2 coins had to be what? Heads, right? So we're looking for a probability where the first 2 coins are heads. That we can't change. So what we're going to look at is what happens on the last one. Well, what are the only 2 options left? We can get heads, and another what? Heads? Or we can get heads, and a what? Tails. So we know that there are only 2 possibilities. What is it that I don't know? The total number of possibilities for the tossing 3 coins. Okay? But we're going to be using a reduced sample space to be able to do this. So hold on a minute. So we can't do that without looking at the sample space. Let me get to the sample space here. So here's the sample space for 3 coins being tossed. Heads, tails, blah, 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 right? And you could make that sample space. You just have to be really careful about getting every combination. How many possible outcomes are there here? 8, okay? Now, but we're only concerned with the outcomes where the first 2 coins were heads. So, looking at those, it's this one and this one. Because if you look at any of the others, at least one of the first 2 coins is a tails, right? So we did that just by thinking about it, but here we're doing it using the outcomes. So there are 2 possible outcomes where that can happen. You agree? All right. Of these 2 outcomes, only the first one has another head. Therefore, the required probability is 1/2. Okay, because if the first 2 coins turn up heads, what is the probability that the last coin is also a head? So out of those 2 top ones that we're allowed to consider, okay, so let me just go through that and explain it. There are only 2 possible outcomes that we're allowed to consider, right? These 2. So is my sample space still 8? No. Because I have that conditional probability, the condition that I have to meet, now my sample space is only 2. Okay? So I won't be doing something out of 8. I'm going to be looking at which one of these 2 has a heads as the third coin. And it's that one. So it's 1 out of my 2 possibilities. Okay? So be very careful. When you have conditional probability like that, where they tell you that you have if or given that, it's going to reduce the size of your sample space. Okay? So if given will reduce the size of your sample space. So say you were looking at students at Queen Margaret, right? But they must be in Year 12 math class. I've just reduced the size, so I can't consider every student in Queen Margaret. I can only consider the students that are in this class. Does that make it clearer? Okay, so what happens was, if you put any conditions on it, then it'll reduce your sample size, right? Which changes your probability. So be careful about that. All right? We can also have that happen to us when we're given the information in a two-way table. So look at the two-way table here. The results below are a survey of people who were asked to choose their preferred holiday destination of Milford Sound or Lake Rotorua. You'll see it's broken down by male and female and which place they preferred. They've gotten their totals. So this is a complete table, right? Again, remember, in your homework, some of these might not have the totals, or they may have missing pieces that you have to find. The results in the table tell us that the overall sample size is 200, but if we want to find the probability that a randomly selected person prefers Lake Rotorua, given that they are male, then we change our sample space, right? In other words, we are only allowed to consider those who are, what? Male. So this becomes the only column that we can think about, which means that the total or sample size is what? 85. Okay? So you get a reduction of those people. And out of those, how many of those males preferred, what was it, Rotorua? Yep, 65. And that will reduce, and of course, you know, y'all have to do that part, so anybody want to tell me what that's going to be? There you go. Or you could do it as a decimal. I'm perfectly happy with that, right? Okay? So, anytime they give you a restriction on these, and that's the hardest part of using two-way tables to find information. Now, in this one, it's very straightforward, which is going to be, it's what you're going to see, is they're giving you very straightforward. You can only consider males and see their preferences in this case. Okay? What if I said that you're restricted to only those people who chose Milford Sound? Then what am I going to be using? This number here, yeah. And 80 is my total, and then I have the 2 probabilities, right? Okay? So find the one they restrict you to. Okay? So if I was restricted to females, if I was restricted to only females, then I could use this column only, right? But what if it said, of the people surveyed? What do you think? Yeah, that's just everybody. There's no restriction at all on that. Of the people surveyed would mean everybody surveyed. Of the people surveyed, how many wanted to go to Milford Sound? That's the total of Milford Sound out of the total. Okay? I haven't been to Milford Sound. Have y'all been to Milford Sound? It's really beautiful. Can't wait to go. You haven't been, or you didn't like it? You haven't been? I want to go so badly. Okay. Sorry. Can't help it. I'm still so excited about New Zealand. Okay? So here we have choosing a random student who studies dance. I'm only allowed to choose students who study dance, which is this. But what's missing? You betcha. And you cannot answer these questions without putting in those total sections. Okay? I mean, you could. You could just do the math in your head. These numbers are pretty small. But it's better if you fill out the chart, get it all complete before you start working. Okay? So they may leave some stuff out. So put those in. Okay? So then you would only be considering the people who chose dance. How's it look? That's 3 sections. Not bad? Okay? All right. Typically, it's not the math and probability, it's the understanding of what they're asking. So make sure you read carefully, right? Like the goldfish thing. It wasn't out of all the fish, it was just out of the 130 we selected. Okay? And you want whole goldfish. Hopefully. Good deal. Okay. So